All right, in this video, we're going to go through an example of solving a tan equation. Okay, so when we solve an equation with tan in it, well, I guess there's a couple of things to think about. Firstly, most of the methods in terms of the way we solve sine and cosine equations are actually the same, and we can apply them to solving tangent equations. Really, the big difference is the last step, because you might remember that in the last step, when we're solving a trig equation by hand, we often add or subtract the period of the function to find any extra solutions. But with a tan function, we just got to remember that the period is pi on n instead of 2 pi on n. This note here as well, recall also that tan theta is equal to sine theta on cos theta. That can come in handy in certain questions, which we'll see in a moment. So let's have a look at how it works. Example 22 says solve the equation tan of x minus pi equals 1 on root 3, where our domain is from pi to 4 pi, not inclusive. So remember that, so step one, when we're solving trig equations, sine, cos, and tan, is to try to find what you might call the base angle. So if we think of it like, you know, tan of some angle, and the phrase I like to use is base angle, equals 1 on root 3. Well, if I'm thinking what angle, tan of what angle equals 1 on root 3, if I'm not sure what that is off the top of my head, I'm going to sketch my triangle that has 1 and root 3 in it. Now remember that tan is equal to opposite over adjacent. So if 1 is the opposite and root 3 is the adjacent, then my angle must be up here, right? And that angle in the triangle is pi on 6. So my base angle, so to speak, is equal to pi on 6. Next thing I'm going to look for is to go, okay, well, this is tan of an angle that's giving me a positive number. So I need to know the quadrants that tan is positive in, and it's positive in the first and the third. So I know that my solutions, or at least my first two solutions, will come from thinking about the first quadrant and the third quadrant. And so I'm going to say, okay, well, now I'm just going to let my angle equal the value in the first quadrant and then also the value in the third quadrant. So x minus pi will equal, well, the angle in the first quadrant is pi on 6. And that will give me x equals pi plus pi on 6, which is 7 pi over 6. But I can also say, so that was my first quadrant answer. My third quadrant, sorry, I should make my work a little bit clearer here. So that's from the first. From the third quadrant, I can say, okay, well, if the base angle is pi on 6, then a third quadrant angle is really pi plus pi on 6 there. So I'm going to be saying that my angle, x minus pi, equals pi plus pi on 6. And therefore, x minus pi equals 7 pi on 6. And if I add the pi over, I get x equals 7 pi on 6 plus pi. And so x equals, well, that's 6 pi on 6, 7 pi on 6 altogether. That gives me 13 pi on 6. So let's think back to our domain. It was from pi to 4 pi. Now, both of these solutions are between pi and 4 pi. It might also be helpful, you might remember from when we did sine and cos equations, to think of the endpoint of our domain in terms of whatever your sort of denominators are in your solutions. So if these are both over 6, might be just worth reminding myself that 4 pi is really 24 pi on 6, right? So anything over 24 pi on 6 is going to be outside the domain. And let's see, I've probably left myself not that much room here. I'm going to make a bit of a mess of this. So for further solutions, I'm going to just add or subtract, generally speaking, the period. And the period for this question is pi on n. And you can see the coefficient of x is 1, so n is 1. So the period will be, I'm going to add or subtract the period, which equals pi over 1, which of course is just pi. Right, so I can take the answers that I've got, 7 pi on 6 and 13 pi on 6, and I can just add pi to them. So I can also get x equals 7 pi on 6 plus pi. And so x will equal 13 pi on 6. Actually, that's the one I've already got. That was silly, wasn't it? Because, of course, these two solutions were already just one period apart. So that was a bit of a waste of time. Apologies. We can take 13 pi on 6 and add pi. And remember that pi is really 6 pi on 6, so I'm going to get to 19 pi on 6. And I could try to add the period to this answer again as well, but you can sort of do that in your head and go, well, if I add 6 pi on 6 again, I'm going to get 25 pi on 6, and that's just outside the domain. So I'm not going to bother continuing adding the period to any more of these solutions. Could look back and say, well, should I have subtracted the period from my lowest answer? If I took away if I took away pi here, I'd get 1 pi on 6, or just pi on 6, and that would be outside the domain as well, because remember that the domain started from pi. So my solutions are 7 pi on 6, 13 pi on 6, 19 pi on 6. My working's a real mess here, so I'm going to write my final answer nice and clear, and I'm just going to say that x is equal to 7 pi on 6, 13 pi on 6, and 19 pi on 6, and I might even put a box around that so that anyone marking my work knows that's my final answer, and hopefully gives me full marks. Okay, we'll go through at least one more in this video. This next example is an exam question, but it mentions the little trick that we talked about at the very start of that video, or this video I should say. So this one says to solve the equation root 3 sine x equals cos x for x is an element of negative pi to pi. You might wonder why this is in the section on tan equations, but you're going to see pretty soon why this is actually a tan equation, even though tan is not written anywhere in there at the moment. And that's because if we were trying to solve this, well, one little trick that we can apply is to say, well, okay, I can divide both sides of this equation by cos x, and if I do that, well, the equation is going to become, and I'm going to write this square root of 3 just separately as a coefficient. It's going to be square root of 3 times sine x on cos x equals cos x over cos x. Well, I know cos x over cos x is going to be 1. And I also know that sine x over cos x is the same as tan x. So this is really root 3 tan x equals 1. And if I divide both sides by root 3 here, then I'm just going to be solving the equation tan x equals 1 over root 3. All right, and that looks a whole lot easier than trying to solve an equation that has both sine and cos in it. So there you go, there's our tangent equation. Now our job is to solve it. It's a pretty similar one to the last question actually. The base angle is going to be the same as well. So let's see, using our triangles, I might write over here. Again, once you practice these, you might just remember them and not have to draw this out, but if you're in any doubt, draw the triangle. So we've got 1 on root 3 this time, which means it's opposite over adjacent. So the opposite side needs to be 1. Adjacent needs to be root 3. So if 1 is the opposite, this is my angle here, and that angle is pi on 6. And so the base angle equals pi on 6. In this case, it's just tan of x, so that makes our job of solving a little bit easier. It's tan x equals a positive number. So we think about where tan is positive, and that's in the first and third quadrant. So for the first quadrant, we've got the angle, which is just x, equals pi on 6. And there we go, there's an answer. For the third, we're going to get x equals, well, third quadrant, it's pi plus the base angle, so pi plus pi on 6, which is 7 pi on 6. And if we need to, we can take these two answers and add or subtract the period as often as we can to keep getting solutions that are within the domain. Looking at the domain that we had though, negative pi to pi, well, that tells me something straight away. It tells me that 7 pi on 6 is actually outside my domain, so I'm not going to include it in my final answer. And I'm obviously not going to add to this because I don't need any bigger solutions, but what I might check is whether I've got some solutions that are smaller that still fit within the domain. So I'm going to subtract the period of this graph. Remember, it's pi on n, right? So in this case, it's pi over 1, which of course is pi. And so if I take pi on 6 and subtract the period from that, well, I'm going to get negative 5 pi over 6, pi on 6, take away 6 pi on 6. And that is just in the domain. If I take away another period, I'm going to get negative 11 pi on 6, which will be outside the domain, but negative 5 pi on 6 is inside the domain. So my two answers that are in the domain are those two. And just to be sure, I'm going to write them out at the bottom of my working. To show really clearly that those are the answers to the equation root 3 sine x equals cos x within the domain x is an element of negative pi to pi.